In this video, we're looking at solving trig equations using a calculator. So not all functions can be solved, this is from the book, can be solved exactly using only the unit circle when we must solve an equation involving an angle other than one of the special angles that we cover. We will need to use a calculator. Make sure it's set to the proper mode, either degrees or radians, depending on the criteria of the problem given. So use a calculator to solve the equation sine of theta is 0.8, where theta is in radians. So let me bring over my calculator. I'm just going to use the one on the computer, obviously the Windows one here. And it's on which view? It's on scientific view. See that? So it gives me sine, cosine, tangent. But I need to solve this, so let me move that out of the way. I want to know what theta is. So theta would be, my pencil just went to sleep. Theta is sine inverse of 0.8. So as you see here, my calculator is in radian mode. I don't have sine inverse, so I hit the I and V button, give me the inverse. And then I'll do the way this one, I think this is like reverse logic. So 0.8, then hit the sine inverse button, also called arc sine. So it's 0.927295. Let's go with that. 0.927295. .927295, and that's it. I was trying to think, do we need to worry about, I guess if we wanted to generate all the values, we could say theta is 0.927295 plus 2 pi k. I guess I need to look at the other one, right? Because this, I forgot, yes. This only returns values from these two quadrants. There's also something over here in this quadrant. So let's think about that for a second. If this angle here is going to be 0.927295, its reference angle from this one, 0.927259. That's the reference angle. So the other angle in the other quadrant that wouldn't be given to us from the arc sine function would have that reference angle. So this other angle, theta prime, would be pi minus 0.927259. So let me see. I don't know if I could do this or not. I want to say pi. Let me do this. I'm going to make this negative. There's my plus or minus button. There we go. And then I'm going to add it to pi. There we go. So 2.214297. So the other theta, 2.214297. Plus 2 pi k. So here's your answers. Okay, yeah, we always have to look for the other place that this would have a solution. Okay, let's go on to example 5. Use a calculator to solve the equation. Secant theta is -4, giving your answer in radians. Okay, so here, remember secant is 1 over cosine theta. So if 1 over cosine is -4, cosine of theta is -1/4. So we would do theta is cosine inverse of -1/4. Now again, as we discussed in the last one, cosine cosine inverse will return values in these two quadrants because it gives you positives and gives you negatives. But cosine is positive here, negative, negative, and positive. So we're going to look at the angle in the second quadrant and then find the angle with the same reference angle in the third quadrant. So we'll look for something down here too. Okay, so let's drag the calculator over. So we do, I need to do, clear this off. -4, negative, nope, 0.25 negative, and then I'll do inverse cosine, so it gives you arc cosine. So this gives us a theta of 1.82, sorry to move it while I'm talking, if it makes you dizzy, 1.823476. I'm just trying to find a good place to round it. 1.82348. How about that? I'll say theta is 1.82348. Let me verify that that was correct. 2348, because that rounds it up. Okay, and that'll be plus 2 pi k, plus or minus, I should say. I guess I should go back to the last one. Plus or minus. I usually don't do the minus because I usually my cake is an integer, so I think they're using k as only a natural number here. So integers can be negative. Okay, let's go to the other part of that. So what is the reference angle here? What is theta prime? It's going to be pi minus the 1.8, excuse me, 2348. And that'll be what? I think it's around 1 point. Let's get the calculator up. So I'll make this, again, make this negative and add it to pi. I get 1.318116. I guess if I go to the same number of places, 812. So theta equals 1.31812 plus, no, that's not it. No, hang on, Jeff. Don't do it. Don't do it yet. Okay, that's just the reference angle. Okay. And that's an approximation. So, okay. Now, that is a reference angle here, and to get that reference angle, that is, so given the reference angle, that's how far past pi it's gone. So we're going to be going past pi that much. So we'll take, the angle is going to be 1.31812 plus pi. And what would that be? So we're going to add pi, and I get 4.4597087. So I'm going to say 4.45971 plus or minus 2 pi k, or 2k pi. It really doesn't matter. So there's one answer, and here's the other answer. And that's how you do these problems.